Hi everyone, this is Angie over at Angie's Beyond the Lecture, and today it's a fine Friday morning here, and I'm going to cover a couple of indirect variation problems in continuance with what I put out yesterday on YouTube. And as always, this handout that I'm working on, it's out on my website. So if you'd like to go ahead and click on the link in the video description, it'll take you out to my website, and you can go ahead and download it there or view it later, however you want to do it. So one moment, I'll get you started. All right, we'll start off with Newton's second law. And FYI, I put on a couple of physics problems here for simplicity. I'll even put on, at the end, I'll put on maybe a gas law problem here for chemistry, but the concepts, of course, are the same across both subjects. We start off with F equals ma, Newton's second law. And when we double the mass and keep the acceleration the same, they'd like to know what happens to our force. So we have F equals ma, and again, doubling the mass, right? Yeah, 2m, and we'll just keep a the same. So what happens here? Really, we just have 2 times ma. Okay, so remember direct variation. If you apply a change on one side, you just do the same to the other. So in essence, we end up with 2 times ma. So our final answer would be, we would be taking 2 times f, or we could say in short that we're going to double the value of f for this answer. So, and I did put this down here on the bottom just as a reminder that when you have direct variation, if you have a variable that changes by a particular factor, you just duplicate it on the other side. So we doubled mass, and that in essence, doubled the entire ma product. We'll go ahead and double the f as well. So pretty straightforward here. When we have, again, f equals ma, we're going to cut. Now in part B, it says we're gonna cut a in half. Times m. Okay, I flipped a and m around. Okay, so in essence, we've again, we've 1/2 times ma. Okay. Now remember, these two are on the same side now. We're talking about keeping f the same and manipulating a. So what do we do with m? So if we have, I'm just going to keep these separate like I had before. So I'm going to go back up to 1/2 times a times m. So if we have, to keep f the same, if we cut a in half, we do have to double our m. So in essence, we're just inverting that. We're flipping that over to say, okay, if we have 1/2, we can double m. And if you think about it here, I'll run through the math real quick. We have 1/2 times ma. All right, so we clean that up just a little bit. We have 1/2 times 2 times ma. 1/2 times 2, that cancels out. So we're left with back to ma, because remember, we're just manipulating a, and then what do we do with m? So again, we just invert that change. If we cut a in half, we're going to double m. So the final answer here would be double our mass. To sort of, we're countering that particular change on a. Now Coulomb's law is, we're essentially saying we have a force. Electrostatic force is the product of a constant k, and on the numerator of this fraction, we're taking the product of our 2 charges and dividing out by radius squared. Radius is just the distance between the 2 charges. So in physics, we'll refer to it as r for radius. Now what we're asking here on part A is, if we change the radius, we're going to double it and keep everything else the same, what happens to our force? So we can look at that real quick. Actually, I'm going to, because that's not the same, we're going to alter it. We're going to say now F is so I put the 2 in front of the R and I square that whole group. Okay, 2r times 2r is actually 4r squared. So we have a multiplier down on our numerator. It's 4 times r squared. So instead of having our original r squared, we have 4r squared. How does that change our f? How does that change our f? Keeping everything else the same. Again, how does it change our f? Well, we'd have to recognize that this is an inverse relationship, okay? And we can look at it, put this off to the left here, f equals, we'll just say, to simplify things, k times q1 times q2, we'll just call that constant. We'll just call it constant a. I don't want to use k again. So f equals a over r squared. So we do know we have an inverse relationship going on here. You could even write it as this if we cross multiply. Remember, a is constant. F and r are together, on the left hand side. So I know if I make a change, so in essence, I'm putting a 4 out there. Okay, so if I just kind of move this over here, I'm taking f times 4r squared equals, again, we'll just give that group a constant a. Well, back to inverse relationships or indirect relationships, if I increase the r squared by a factor of 4, I would decrease the force by a factor of 4. So our final answer here is going to be that so we just determined that we're taking force and we're going to decrease it by a factor of 4. So we would just say decrease by factor of 4. Okay. And then on the flip side, if one of the charges Q1 is tripled, keep everything else the same, what happens to the force F? So we would be looking at R squared. Okay. So we have an increase of a factor of 3 on top. We're not manipulating K or Q2, and I should make it clear that's a subscript. Sorry about that. So we're not doing anything with K or Q2 or R squared on the bottom. We're just saying, all right, well, we'll take Q1 and we'll triple its value. So when we know it's a direct variation, again, if we have an increase up here, we also have an increase over here. So if we increase Q1 by a factor of 3, we would also increase force by a factor of 3. So we could say triple F, or increase, I'm just doing shorthand here, increase by factor of 3. All right, so conversely, if we're to flip things around, maybe on part B of the second question, if I maybe cut the charge in half, we would likewise do a cut of, overall a cut of force in half on the left-hand side. So whatever you apply in the right, you apply in the left in this situation. So I hope these examples help, and I'll go ahead and add one of our gas law problems. So for instance, and I did this yesterday on the one of the actually both sample problems, but I'll go ahead and run through it again just to add chemistry to this. So ideal gas law, PV equals nRT. Okay. And we'll go ahead and we'll use Boyle's. We know Boyle's is, that's an inverse relationship here. And PV, if we keep nR and T the same, so if we keep number of moles, and of course our constant is constant, and if we keep the temperature the same in our system, we know there's an inverse relationship between pressure and volume. I'll just call that constant K. So this entire part is, in this particular scenario, is not going to change. We can declare that, and I'll just define it as K, and P equals K over V. All right, so if I have, now notice nothing is squared here, nothing, these are just going to be direct changes here. So if I increase my V by a factor of, say, 3, what happens to my P? What happens to my P? All right, so P, what happens here? So what I'm saying, okay, so if we know it's inverse, I would simply say, well, P is going to have a value of 1/3 of the original P given in the problem. We don't know what it is. These are arbitrary. So I would say 1/3 P, 1/3 the original P. And then likewise, let's do one where we have P equals K over V. If I increase my pressure by a factor of 4, what happens to my V? All right, so what I'm saying is, all right, 4 times P equals K times V. And we know this is an inverse situation. So we can know right away if we increase P by a factor of 4, we would decrease it by a factor of 4 on the volume side. Well, yeah, let's keep that black. So 1/4 V. So you can write it numerically. You can just say it's 1/4. You know, in the previous problem, you could say it's 1/3. But these are the types of problems that you would see in chemistry and in physics, where they're just going to give you a situation, give you all the variables, right? And they're really not going to give you numbers. They'll just say, okay, I have a situation. What happens when I manipulate one particular variable? What's the result on the other one? And then you have to give that result. So your typical answers are going to be doubled, tripled, maybe quadrupled. You can even have a factor, you know, higher than that, depending on the situation. And always, as a reminder, back to A. So notice we doubled R, but R is squared. Okay, put those parentheses in and make sure you track those changes. We're not doubling. Yes, we are doubling R, but we're increasing that overall denominator by a factor of 4. So again, I hope this helps with direct and indirect variations and problems that you might see. I'll go ahead and put the write-up, you know, the worksheet, including the write-up, as well as a blank copy on the website. And hit like and subscribe if you want to see more content as it comes out. Appreciate you watching. Have a great day.